Alright, what's up guys? We are going to build a pulse width module tonight. I have got all of the materials prepped. I've got the soldering iron good and warmed up. I believe we are actually truly all ready to go. I gotta trim up this one spot here because I don't like it. Okay. So, I want to talk about this real quick. Pulse width modules are amazing. There are basically a unlimited number of applications. I can't think of a number. There's so many different applications for them, it's insane. Anything that needs a basically a regulated, unregulated voltage. Anything that you need to adjust the voltage, any kind of inductive load, small motors, heating elements, whatever it is, what have you, perfect for that situation. Lighting. With that being said, when you are using a pulse width module, it is not actually adjusting the voltage at all. No matter what, you're not actually changing the voltage. All the pulse width module does is cycle on and off really fast. That's all it does. By adjusting a potentiometer on the pulse width module, you can adjust the duty cycle, the amount of time that the power is applied during each pulse. A 50% duty cycle on a 12 volt signal gives you 6 volts out. You're still getting a 12 volt pulse every single time. With that being said, I'll get right up here next to it. I got some of these bad boys. These are 6,200 milliamp hour 40C LiPos. These are technically 4 cell. They're 2 series, 2 parallel. 8.4 volts fully charged. So these are the LiPos I'm going to use for my 2 series box. I've actually got 2 of them. They are quite powerful. 250 amps, or technically 248 amps continuous. The pulse rate on these is 60C. I actually haven't worked out the amps on that, but I know that the continuous is safe to a 0.035 ohm build. That's pretty freaking intense. I don't know of anyone who does that consistently or on any kind of regular basis whatsoever. I know I certainly don't do that on a regular basis, and I don't recommend you do, because you're going to need more than this to be able to run that. You're going to need at least something like this to be able to run that. Most people don't. With that being said, yes, technically it is pulsed. Depending on your components, you can use the pulse ratings for everything for your amperage and all of your figurings. But when you adjust it to a 50% duty cycle and you technically are measuring 6 volts with a meter capable of measuring it correctly, from a 12 volt, let's just say 8.4 volts, you're measuring 4.2 volts at 50% duty cycle. This doesn't see 4.2 volts out. It's still putting out 8.4 volts just half of the time. So this is still pulling. If you've got a 0.035 ohm build on it, this is still running 248 amps on every single pulse. You are going to destroy your battery and potentially hurt yourself if you do not use proper rated batteries and equipment. With that being said, a 0.07 ohm build will only pull 124 amps. That's why super sub-ohming is so dangerous. Obviously, any of you who have done this for any amount of time or have any knowledge about Ohm's law understand that. This is not something that you can just throw together, put in an 18650 box mod, and I can run a 0.02 ohm build now. You can't. That is extremely dangerous. This is my disclaimer to you guys. You need to use proper rated equipment. I will show you the 510 when I go down. I'm actually using the tripod that I ordered, so I finally have a good camera system. You're going to get to watch as I build the entire thing. Don't do stupid shit. That's my disclaimer. If you don't understand it, don't use it. If you want to understand it, and you don't, if you haven't been able to find a good enough explanation, feel free to message me on here, or comment, or I will link my Facebook page. Feel free to get on there and ask all the questions you want. I will answer to the best of my knowledge. That's basically as far as I can go with it. Otherwise, you guys are on your own for safety. That's something that you really need to be careful with. With that being said, let's do some close-ups. Make plenty of noise. Get the tripod set here as clumsily as I can and as shakily as I can, and give you guys some terrible video quality in the process, which is the exact opposite of why I got this thing. Here we go. Oh, Windows XP, it's obsolete. Okay, this is what I have for you. Not this in particular, that's just a bad angle. What I have done is done a very crude drawing of the schematic. It's got components all over it where they'll sit. This is the strip board that I have prepared. There are a couple places that I broke the connection that weren't necessary, but otherwise, this is it. I've got the wiring right here for it. I'm going to explain a couple things real quick. You have 3 wires coming out of the circuit on this side. You've got your positive, your negative, and then your MOSFET gate wire. On this side is your potentiometer coming out. You can connect it directly. You can just connect the wires directly in the holes. I'm using stranded 22 gauge, and I have separate colors for different things. Green's going to be the gate, red and black positive and negative, so on. But I have had a lot of trouble with the wiring breaking off at the circuit board. I really don't like putting hot glue on them. I feel like it takes away, it degrades what it should be. But without any further ado, let's get started. I've got the basic layout for everything already drawn on here. If you're curious about the size of the board, each hole is spaced a square millimeter apart from the rest, or a millimeter apart. So 1, 2, 3, 4, 5, 6 wide. We'll say 8 millimeters wide just with the sides of this, by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 14 millimeters wide. So 8 by 14 millimeters. This is fairly small. If you'll notice, which you may or may not have, the 555 is not out here with everything else right now. It's like the holy grail of 555s right there, guys. That is, I believe, 48. Yes. 555 timers. These are all brand new, gorgeous. I do not have any more 8-pin sockets to attach this to the circuit board. So until then, this is going to be for my personal use anyways for my next box, so I have no problem mounting the 555 directly to the board. Let's get started. Let's stop talking. So the first connection is to connect pin 2 to pin 6. We're just going to put this in here, and we'll solder a couple as we go. I'm not too concerned about anything falling out of it. Okay, and then we have pin 1 here to ground. I have already pre-cut. This is a 24 gauge tinned bus wire. It's solid. It's wonderful for doing strip boards. If you have done them any other way in the past and you haven't used this, I highly recommend getting some. It's very cheap, just a couple dollars. I usually get most of my supplies at Radio Shack. What I can't get there, I get on Amazon. And then pin 4 to positive. Yes, I know this is not an extremely well-made diagram. I've showed the diagram multiple times, and I'm more than happy to share it with you if you contact me and ask. So basically what I'm going to do to start here is just put all of my jumpers in place. I think I bent that one a little bit. Okay, this is pin 8 to positive. What's left? We've got here we go, pin 6 to the center side of the potentiometer. What's left? Pin 1, which is ground, will connect to the center contact on my junction block. That makes life so much easier using the junction blocks. They're a couple dollars on Amazon for like 30 of them, and if you aren't building a crazy high power box, they're rated 8 amps at 250 volts. So if you wanted to put the MOSFET on the circuit board and use those as junctions for everything, you absolutely could. I wouldn't recommend it. It's not going to be able to handle much power, but it is totally feasible. Okay, here we go. Here's all of my jumpers in place. I'm going to solder all of these and trim them up. Okay, daughter came out here. Okay, so we're going to flip this over and solder all of these in place. Whoops. Maybe I should make sure these are in a little bit better before I go doing that crap, flipping it over. You guys are getting real up close and personal with my hands. Okay. Ta-da! Let's solder some connections up. This is going to be difficult because my hands are on either side of the camera and my face is directly behind it. So this is going to be exciting. Let me just think for a moment. We'll deal with it when we get to it. We're just going to solder everything up. Shoot, I need something to hold it in place. Luckily, I have a big steel block. That should keep it from moving. Here, let's adjust this just a little bit. Give you guys a really good up close and personal view of it. It's probably a little closer than you want. Zoom out just a little bit. There you go. Okay. Obviously, I probably could, if I did some editing, I could probably just voice over this entire thing and save you guys a lot of irritation listening to me talk. But where's the fun in that? Plus, I'm sure that my microphone is picking up all kinds of wonderful noises. Let's adjust this angle. Actually, let's trim some of these off while we're looking at it. I give myself about a 50% success rate doing this. Half the time they come out perfect, and half the time I can't get them to work for anything. So it's just a matter of being super delicate with your work and paying very close attention to what you're doing. Oops. Damn it, just like that. See that? Crossed over on them. Luckily, I can just heat it. Well, look at that. Woo, it focused. Okay. Good as new. Like I didn't ever screwed up. I'm really enjoying using the camera like this, just so you guys know. Come on, sweetheart. There's plenty of methods of cleaning a soldering tip. My favorite is to just hit it on the table. If it gets bad enough that I have to clean it, I can always take a wire brush to it. One more here. And then we'll nip these off. We will make sure that I didn't miss anything. Don't those solder joints look oh, I love it when they drive out like that. Ooh, gets me so excited. Don't those solder joints look wonderful? Very, very simple. Okay. Zoom back out here. Next step. Make sure that we've got the board right set up. 1K ohm potentiometer. Just a little 1000 ohm for pin 7 to ground, or to positive. And this is actually because in this configuration pin 7 is actually not used. So the solution is to use the resistor to not actually entirely sure what the purpose is. It keeps it from blowing anything up by not going where it needs to, by maintaining voltage at pin 7. If I wasn't distracted doing this, I could probably give you a better explanation. Too much solder. Jeez, that's an ugly solder joint. Okay, we can live with that. Okay, I'm back. Oh. Alright, so where were we? Got the resistor on here. Was having trouble explaining why. Okay, now we've got 204 microfarad capacitors. Or I'm sorry, code 104 capacitors. One of these ties pin 5 to ground, and one ties pin 6 to ground. We are not going to worry about, we're going to do them one at a time. That way I don't lose them off the bottom of the circuit board. If you guys don't like me zooming in on the circuit board and soldering this, please let me know, because if you don't care for it, there's no point in me doing it. Ah, see, I got solder across it again. My tip is loose. How did I manage that? I think that fixed it. Okay. Now we should get a better solder joint. Much better. Whoops. Focus. Yep, still there. Dang. Geez, that is hard to get that to break loose. That's why if you're just careful to begin with, it's a lot easier. Got it. Okay. Now I gotta put more solder on it. I'm sure you guys are probably already sick of this and are checking out. Those of you who aren't, I appreciate you dealing with me and putting up with me. I'm certainly playing here. Okay, now the other capacitor ties pin 6 to ground. The capacitor that ties pin 5 to ground serves a similar purpose to the resistor tying pin 7 to ground. This is simply to give pin 5 power. The capacitor to pin 6, along with the potentiometer, sets the frequency for the pulse width module. Don't ask me exactly how it does it, because I have read through multiple times on the data sheets, and it is not so much confusing, it is just boring. It's hotter. There it goes. Okay. Now what's left? All that is left here is... Okay, so we're at the point that I said we would deal with this after the fact. There are two things that I have to do now to get these ready. Firstly is the strips on this run horizontally. I have broken the strips where it is necessary in order to ensure that everything functions properly. However, where I put this specific jumper and these two jumpers are actually the holes that I intended to use for the legs on these. Also, these legs are just slightly larger than these holes, only because these are square. So the solution, one of the solutions, is to widen the holes with the tip of my tweezers. That part's done. Now we got to do this side. This will probably be enough to keep it from working, but we'll worry about that later. Okay, I could actually remove this jumper and put it up here now, but that would just defeat the purpose of moving it at all. On this side, however, I am going to have to break the connection here. On pin 3 should already be broken. Yes. This side of the board is straight. This is probably extremely boring for you guys. I apologize. This is why I have put it off for so long doing a video like this, because I am extremely boring when I build this kind of stuff usually. Okay. Something to consider with these, you can only access them from one side, so you better make sure that's the side you want to access. I should be able, because this side is already broken, to just stick these directly in after I widen the holes a little bit better from the back. Yes, that is called tweezer torture. It's okay. They don't mind. The final step will be the 555 timer. I'm not worried about anything else or about it until I get everything else in place. These holes are fairly snug. Okay, that's one side soldered on, and you can see they are fairly large, but as I said, these are rated 8 amps at 250 volts. They're fairly tough little circuit mount switches. And these are spaced 3 pins apart. Technically, there's only 1 pin between them, but they connect to every other pin, which actually kind of makes it difficult to work them into this correctly. Okay, now if we put this here, I'll actually need to break the connection. All I use to break the connection on this is a, what size is this? I believe that I have worn the number off of it. This was originally a 960, this is a 9/64 drill bit. So all I'm going to do, they make little hand drills specifically for this purpose, but this works perfectly fine. We just broke this connection right here so that when I put the circuit, or when I put this on, it will not short to pin 8, which is a very bad deal. So we can actually cut this jumper from pin 6 because it's going to be directly in line now. There's no need for this jumper to be here. Poor planning. Poor planning. In multiple ways. Now I actually do have to make a jumper for pin 7. I'm really starting to understand why so many YouTube channels have the high-speed footage of them assembling everything, and they just voice over key parts, because this is taking forever. And it'd probably take 5 minutes to do a voiceover of this in high speed. Okay. So, since I have to make a jumper, my 24 gauge solid wire, we will just bend it into the shape of the jumper that we please. Yep. I think that's too long. Completely off topic of the pulse width module. Friday, in 2 days time from when I post this video, I will be having my wisdom teeth removed. And I'm super stoked. I'm just so excited. I'm really not looking forward to it. We're going to set this under here to hold that in place and solder that in. This is simply a jumper from pin 7 to make it easier to connect it to the board. And I really didn't need it at all. But whatever. Waste of time. I forget that I'm working with strip board and the connection goes all the way across. I overdo it when it doesn't need it, and then forget the important parts. Okay, I'm happy with that, or as happy as I can be, whatever. Just make sure that's pressed down good. This is basically, minus the 555 timer in the middle, the finished product. Obviously there are a few key features missing. Got that jumped there. This needs to just connect directly to the strip board. Ta-da! Okay. Make sure I like all of that. And then we'll flip this over. Now, here's where I could potentially screw it up. Let me zoom in for you. Okay. This end is the end where was the side of the strip board, and if you'll notice, each one of these is separated into their own little squares of copper, which is great, except that I forget about that when I'm doing this, and it can cause havoc. This is my positive rail, this is my ground rail. I could actually potentially solder each of these in place without jumpers and have them almost where they needed to be. But I cannot do that now because I already have jumpers in place. I am having to make jumpers using solder. Beautiful. I think that works. Okay. That should be good there. And that should be good there. Except that that did not make a connection. This is as small as I can possibly make it. If I made it larger, I probably wouldn't have near as many issues also. Super soupy welds is solder joints, what they are. I should be ashamed of myself for putting this on my YouTube channel. You guys don't deserve to see this terrible stuff. Okay. I am going to call this acceptable. Now for the heart of the machine. Dun dun dun. This has a little notch in the top to denote the top, which is pin 1 on the left. Boom. Beautiful. See that little jumper inside there underneath? That's between pin 2 and 6. That keeps me from having to have some huge wire run all the way around and take up a whole extra set of space in there. We're going to flip this bad boy over. And solder it up. We'll get you a good close up on this. Actually, where is my wire brush? As those are in the middle of the circuit board, and I can screw everything up by not soldering in the right place, it's worth it to take the time to clean the tip. Probably should have taken the time to clean the copper traces on this thing, as they are slightly oxidized. There we go. That's probably way too much heat on it. Okay. I think, guys, that it is finished. I guess the only thing to do now... Oh, fuck. It's not finished. Yeah, I just threw it on the table. I don't care. Still gotta assemble this stupid thing. Okay. So there's lots of ways to do this, and obviously I hooked those up wrong. I should have waited to twist them together. Luckily I have like 100 of them. Because you never know when you'll need more of these stupid things. Just a few. The one thing to make absolute sure of when hooking the diodes up is that you have them reversed. And of course I cut that one the same. Dang it. If they're both connected in the same polarity, it will not work at all. 100% will not function. Okay. Let's go ahead and tin these legs so I don't have to worry about it. And for the sake of it, we're going to go ahead and put my center wire on so I don't have to worry about it either. Okay. And I do have a bunch of very small pieces of heat shrink tubing I have pre-cut to size. This is not directly connected to the board. It is mounted through hole in the box and is extremely likely to cause a short as the entire case is metal. So any way that you can help prevent short circuits, only you can prevent short circuit fires. That was actually pretty good. I didn't think of that ahead of time. Put that piece up on there, like so. Oh, I'm digging for a lighter and I got it in my pocket. No, it's not for tobacco or anything like that. My name's not fully spelt right. This was my grandpa's Zippo case from Vietnam. Figured that was kind of worth hanging on to. Carry it every day. Okay. Now, depending on which way you hook these diodes up polarity-wise to your potentiometer will determine which direction you rotate it, clockwise or counter, to change the voltage. I have yet to take the time to actually check which is which, so I basically just guess it each time. I guess it would help if I actually put it up here where you can see it. Okay, we'll solder both of these on. Yes, I go through a lot of solder. I like solder. Okay. Ensure that the polarities are correct. Yes. More heat shrink tubing. Now here's where it gets fun. Cross these two together. Oops, they need to go underneath because this will be up against the inside of the box. Push my heat shrink tubing up on there good. Make sure it covers everything. Twist those together like so. Tin that. We'll tin my positive wire here. Yep. And the final piece of heat shrink tubing, and then we'll finally be able to hook some power up to this daggum thing, get it all hooked up, and see what we can make it do. We're going to put this over all of it for both wires. It may not be code, but it's pretty, alright? Now this large, or slightly larger piece of heat shrink tubing that I put on over the top is my favorite kind. It is most of what I keep. It is adhesive lined. So as you heat it and shrink it, the adhesive melts and actually oozes out the ends. It actually makes for an incredibly solid connection. Okay. Throw that shit down. Who cares about it? Get the soldering iron away from us so we don't burn ourselves. We're going to do it with a 2S LiPo because that's what we have on hand and that's what we need to test it with anyways. Screwdriver and voltmeter. Now, since I'm almost 45 minutes into this and almost no one is still watching this, I'm absolutely certain we can actually start getting to some exciting stuff. I'm not going to for the test video because I've already wasted a ton of time, but I do recommend tinning your wires if you do use these beforehand. It helps prevent individual strands from breaking off out of the lead wire. That's really the only purpose for it, but it does help tremendously, kind of similar to installing speakers in a car. Same principle. This is my gate wire. This will come out of the third one down here. I am not going to put anything there because I'm hooking the voltmeter directly to it. It actually fits my leads damn near perfectly. Okay, potentiometer. Which lead did I hook up to what? Do you remember? Black is center. Black goes to number 6 on the bottom. If you have managed to not turn the video off yet, kudos, you win the no prize, and you might get to watch me shoot sparks out of a circuit board. In which case this video will become very entertaining very quickly. Not safe, but entertaining. We're going to set this on top of here to prevent short circuits. And I think I'll strip these back a little bit more, and we're going to go super safe connection with this. And I'm just going to stick these wires directly into the ends of the battery. Oh my gosh. Some of you guys are going to love that. I know already. I'll just bend these over like so. Okay. Now let's get the LiPo right here. Bring the voltmeter in view. Get this out of the way. We don't need that crap anymore. Okay. Let's see what happens. Contact. 3, 2, 1. It didn't explode. Oh shit, guys. Look at that. Look at that. It might have taken 45 minutes, but you know you guys liked it. There we go. What's that? 7.75 volts. adjustable all the way down to, I can't quite see it, 84.9 millivolts. Now mind you, this is not actual voltage coming out. This is the averaged voltage based on the duty cycle. Well, congratulations guys. You just watched me build my first pulse width module for a LiPo box. While I'm in this view, there's the 510 for the next box. This is machined out of 454 naval brass, same stuff I use for my Maximus RDA. This is the bus bar, solid copper that I hammered out into a sheet. This is a dual 3034 MOSFETs. The drains are soldered directly to the 510 drain, or 510 ground here. Dang it, moving my tripod. They're running parallel. I've got my gate wire, which I actually used black at the time because that's all I had, so it'll screw into this terminal right here. And then I've got 12 gauge silver coated stranded lead wire, I'm sorry, 10 gauge silver coated stranded lead wire paralleled to both of them. This is ridiculously powerful, and this actually threads onto the 510. Boom. And I'll polish this up really well, and I haven't decided yet if I'm going to coat that in silver or not. The threads are fantastic inside, and that gives me a lot of surface area already. But there is that. And here we are. That wasn't edited, by the way. I literally just paused it and moved it and readjusted everything. I probably spent 5 minutes readjusting it. So, all that being said, 45 minutes, I would say, is not terrible, considering that we just made a tiny, tiny little pulse width module, fully functional, and completely modular. You could actually take this and put this into a regular LiPo box. All you would need is a ground. Your positive from your switch, rather than going to the MOSFET gate, would come to here. Your MOSFET gate wire would plug into the third one, and then you'd already have your potentiometer. You just have to drill another hole for that. These could be reproduced fairly quickly if you weren't having to record make every one, and you actually knew what the hell you were doing. I hope you guys enjoyed that. That was very stressful on my part, trying to do that for the camera for you guys. If you liked it, please let me know. If there's anything I can do to make it better, let me know as well. I'm not a camera guy by any means. I'm using my Galaxy S7. I have a Bluetooth headset set up over top of the table recording the audio. I hope the audio is in good shape, because if not, I'm fucked. Because I can't replace an hour's worth of video like that. I really do hope you guys enjoy it. I never intended for it to be anything like this, even as little as the channel is. You guys make it worth making the videos. I wouldn't waste the time with the videos if you guys didn't enjoy them. As I'm sitting here, I finally have a camera set up in front of my face that can do high quality close video. I might as well show you the deck of the Maximus with the coil that's on it in decent quality. How's that sound? Here we go. We're just gonna drop it. Oops. Put this right here. I don't know if you can see that. That's all there is to it. This is the triple twisted 26 Clapton with 36 that I made in my high-speed Clapton video that I freaked out about so much. That was absolutely phenomenal. Flavor is amazing off of this as well. If you'll notice, I haven't vaped off this in a few minutes, and it's still warm enough that it's kind of sort of releasing vapor. It'll do that for a while. There we go. Ooh. There we go. That's better. Golly. Adjust that angle down a little bit. Okay. So, if you guys have any questions or comments or whatever, feel free to hit me up. I will link my Facebook page if you're interested. I'm going to blow some clouds real quick. I think I'm finally killing my lipo after a week. Got it turned all the way up. Yep, she's fading. I hope you guys enjoyed. I really do. Be safe, for sure, and vape on, guys.